We have one lesson left in our unit on congruent triangles. Today we're going to talk about two kinds of triangles, isosceles triangles and equilateral triangles. First, isosceles. I have trouble spelling isosceles, so it always takes me a second when I write it down. So an isosceles triangle, I-S-O-S-C-E-L-E-S. An isosceles triangle has at least two congruent sides. At least two congruent sides. So the two congruent sides, those are called legs. Angle 1, so if these are congruent, those are both legs. That's a leg, that's a leg. Angle 1 on the top, that's called the vertex angle. And angles 2 and 3 are called the base angles. And what we know about isosceles triangles is that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So basically that means if AB for this triangle is congruent to CB, that's a D, CB, then we know that angle 2 is congruent to angle 3. So AB, that corresponds to its opposite angle of 3, and BC, that one corresponds to its opposite angle of 2. So if AB is congruent to BC, then the angles opposite them are also congruent. Now we can kind of flip that, and we can say if two angles of a triangle are congruent, then the opposite sides, or the sides opposite those angles, are also congruent. So this time we're going to start with the angles. Okay, so if angle A is congruent to angle C, then we know that AB is congruent to CB. So if 2 is congruent to 3, then we know that AB is congruent to BC. Let's try this out with a proof. This is kind of a mini proof to start with. It says name two unmarked congruent angles. Two unmarked congruent angles. Okay, here we have two sides that are congruent, which means the sides, or the angles opposite those sides, are also congruent. So that means we've got angle ABC. We know that that is congruent, ABC to angle ACB. It also says to name two unmarked congruent sides. Well, here we have two congruent angles. So we look directly across from those angles, and we have two congruent sides. So that means that AD is congruent to AC. So that's kind of a mini proof. Let's try a big one. Using the isosceles triangle theorem. Oh, we're going to prove the isosceles triangle theorem. Okay, let's see how this works. So given we have a triangle LMP, and we know that LM is congruent to LP. So let's mark that. LM is congruent to LP. Okay, so I'm going to walk you through this one. It's kind of complicated, but it's kind of cool the way it all comes together. There are already some reasons filled in, which are sort of hints. Okay, so this says, reason 1 says that every segment has exactly one midpoint, which it does. And you see this N hanging out right here? Okay, so we're going to say that N is the midpoint. Let's see, let N be the midpoint. Of segment MP, because every segment has one midpoint. Now it says definition of a midpoint is our reason. And remember, we're trying to prove that these two, that angle M is congruent to angle P. So we're trying to prove that M is congruent to angle P. If N is the midpoint of MP, that means we know that MN is congruent to NP. So we know that MN is congruent to NP. Now the next reason says 2 points determine a line. Okay, so perhaps we're supposed to draw a line. So let's take the vertex angle and draw the line LN. I'm just going to say that. I draw LN. Okay. Now we have two triangles. And if we have two triangles and we can prove that those triangles are congruent, then we know that all their parts are congruent. So if we can prove that the top triangle and the bottom triangle are congruent, then we'll know that those angles M and P are also congruent. So how are we going to prove that those triangles are congruent? Well, right now we have sides. We've got the two sides that are congruent, MN and MN. So we've got a side. They share a side. Look at that. So we could say that LN is congruent to LN because of the reflexive property. So that's another side. And then the one that they gave us, LM equals LP, that was given information. That's another side. So now we know that these two triangles, LMN and LPN, are congruent because of the side-side congruence. Now, once we know that the two triangles are congruent, we know that all their parts are congruent. So we can say that angle M is congruent to angle P because, and this is going to take a second to write, congruent parts of congruent triangles are congruent. That's always a lot to write. So we shortcut that and we just say C, P, C, T, C. Congruent parts of congruent triangles are congruent. C, P, C, T, C. Okay, so let's flip over and we're going to try equilateral triangles on the other side. So a special kind of isosceles triangle is an equilateral triangle. Equilateral triangle. And a triangle is equilateral, remember, meaning all of its sides are congruent, if and only if it is also equiangular, meaning all of the angles are congruent. So, as long as A, B, and C are all congruent, then we know that all of the sides are congruent. So because of that, we know that in an equilateral triangle, each angle, because they all have to be the same, each angle measures 60 degrees. So in an equilateral triangle, we always know that all of the angles are 60 degrees. We're going to use that information to solve some of these problems. It says find the value of each variable. So we have a 2x, and we've got this 4y minus 5. Right now we don't have anything that we can use. But what we do have is these two x's, those two angles are the same, which means that the segments across from those two angles are also the same. So this one and this one are the same. This one has a marking of like one red mark, so I'll put that on here too. And now I have 3 red marks, which means that this is an equilateral triangle. Well, if it's an equilateral triangle, all the sides are congruent, which means that 4y minus 5 has to equal 3, because I know that those sides are congruent. So now I can solve for y. We can add 5 to both sides. So we get 4y equals 8. Divide both sides by 2, so y equals 2. So we've solved for y. We also need to solve for x. We know that it's an equilateral triangle. Equilateral triangles are also equiangular. And every equilateral triangle, all the angles are 60 degrees. I know each angle is 60 degrees, which means that I can say that 2x is 60 degrees, so x is 30 degrees. Let's try one more. Let's see what we have. We're going to find the value of each angle again. Now, scrolling in, we can see that these two segments have congruent markings. So those two have the same measurement, which means to find y, I can just set those two next to each other or equal to each other. So 4y minus 2, I know that that equals 2y plus 2. Now I can solve for y, so let's see. We'll subtract 2y from both sides. So we get 2y minus 2 equals 2. Add 2. 2y equals 4. Divide both sides by 2. So y equals 2. I've got that. Now, if these two angles are congruent, these two segments, that means that the angles across from them are also congruent, which means that if this one's 80, this one is also 80 degrees. I can use that all the triangles together, all the angles in the triangle equal 180. So I know that 6x plus 8 plus 80 plus 80 equals 180 degrees. Now we just have to solve. So 6x plus, let's see, 80 plus 80 is 160 plus 8 is 168 equals 180 degrees. So 6x equals, let's see, 180 minus 168 is 12. Now divide both sides by 6, and we get x equals 2. There we go. We've solved both sides, all the variables, using equilateral and isosceles triangles. Thanks for being here.